Okay, welcome back. All right. So the next lecture in this deal with dictionaries is something called nested data structures. Okay, this is actually not anything new. Really, what it is just kind of like a time to pause and say, okay, now let's actually solve some real life problems with things. So I may approach this a little bit differently than just sort of here's a bunch of slides with a bunch of information with some things. I believe that actually, for the most part, it's like here's some problem solving. So we'll work on it this way. Okay. One of the things that I mentioned about dictionaries, especially last class, I mean, okay, great. You look at just what's in the slides and you have a student dictionary. Great. You have a name, an ID, and a GPA, and a phone number, maybe some other things. Although that is reasonable, having a single dictionary by itself is not very interesting. And we did have a bunch of other dictionaries as well. I forget exactly what we ended up doing. I remember doing something with the length of a month as a dictionary. And, oh, I know what it was. We were converting course codes into names, and eventually we tried names in the course codes. All right, so we've had a chance to kind of see sort of more uses of dictionaries. All right, however, like what I said during last class, although a single data structure is kind of interesting, it's actually not what we end up needing for any of our programming. So in other words, when I talk about a list of integers, I mean, yeah, there's some benefits of having a list of integers, but just a list of integers or a list of strings or a list of some other primitive type like booleans, it's not really that useful. However, if we can combine things so that we have lists of dictionaries, this is actually where most of our programming ends up sort of falling. And really, to be honest, most of the stuff we will do through the rest of the course would probably be lists of dictionaries. And even my Web Tech 2 students are basically dealing with lists of dictionaries. Different names because it's a different language, but that's essentially what they're working on. So yeah, this is obviously some programming patterns that pop along all the time. Okay, so I think we won't bother making it. Okay, we'll make it full screen for a couple of seconds. Give me a second. Go wait here and... There we go. So what are we talking about? Okay, one kind of quick warning about the textbook. Okay, the textbook does have a section, it's called Nested Dictionaries and Comprehensions. We don't cover comprehensions in this course, and we will not. They're really, really cool little shortcuts if you're really good at programming. They can make 5 or 6 lines of code turn into one completely incomprehensible line of code. The AIs always like to pick them because they want to give you like single line answers, but I don't find that they're very useful in the context of infs1201. If somebody says, yes, we want it, well, then I would bring it in. I'd start asking questions about it, and you don't want me asking questions about comprehensions. What I can do is maybe I should pull up a description of one before I leave today, just so you can say, oh, it's one of those things. Okay, but in any case, so anything to do with comprehensions, just please ignore it. Will never show up here. All right, and of course, this is exactly my comment that I just finished saying, is that really most real-life applications require complex structures. It isn't just a single list of integers. It's a list of a bunch of properties, like a list of students with GPAs and phone numbers and test scores and all of these types of things. These combinations of things, this is the type of real data that you have to work with. And if you can't work with these pieces of real data, then you won't be able to actually solve any real life problems. Okay, so what I'm going to be doing for the next little while, as I said, I'm going to be pulling out some examples. What I will probably do is I will likely hide some information and I will show you a question, then we'll actually solve the problem together. Well, that's not helpful. Get rid of that one. Okay, and off we go. I guess this slide right here is okay to talk about. Okay, so the very first one I wanted to cover today is a list of dictionaries. So this is a very common and an extremely useful pattern. And it's used when every item you want to hang on to happens to have a whole bunch of individual properties. It's really good for storing records. Okay, please remember this when you take the database course. because when you say the word records, it kind of means something from there. It's really good for storing records like students, products, readings, all kinds of things. Often you have to process them using a loop. Okay, and we're going to see a bunch of examples of these. You have, what else do I put in here? I'm going to do a lot of things where each number is, okay, so you have a whole bunch of data about a lot of different things, and every one of those items happens to have individual values. And usually, it seems like I'm repeating things because it involves iterating through the list of items, but I just said often process using a list. Okay, so I'm completely repeating myself. Any case, there's a nice example at the bottom, so ignore all of the crazy bullet points. The example kind of makes sense. What do I have? I have a list of, what do they look like? The hints are kind of there. Yeah, it's a bunch of students. And each student happens to be what type? Okay, so it's a list. You can tell it's a list because of the square brackets. And inside the list, each of the items in the list is not a string, a dictionary because of the curly braces. Now, inside each of the dictionaries, we have a bunch of, well, we have a whole bunch of properties. We have an ID, which happens to be of type string. We have a name, which happens to be a string. And we also happen to have a GPA, which appears to be a float, wrong course. All right, so there we go. So yes, we have 3 students in total. Okay, excellent. So what we're going to do is we're going to start writing some functions based on this. Okay, now, I suppose what I should do is I should write a description first of the problem I'm going to solve, and then, of course, I will solve it. So let's do this. Okay, I'll type the problem up, and we'll type it in real time. So this is kind of cool. When I write my own problems, I get to change it if I don't like it. Oh, okay, yeah. I know you don't get to do that, but I do. All right, so here we go. Write a function called academic honors. Okay, that takes a list of students. Okay, any more description of that, and returns a list of IDs whose GPAs of student IDs. We'll call it this: of student IDs whose GPA is bigger than or equal to 3.5. Okay, now on an actual question on a test, I would always provide an awful lot more detail than this. Okay, this is just sort of the overview, and I would say I would write this. Okay, so this is what a question would look like. And hopefully I don't have so many spelling mistakes in it, but assuming that we have everything spelled correctly, this is not quite enough for an infs1201 student to write a function. It is enough if I were to go to, say, a third-year student and say, okay, give me the function. They're supposed to be able to come up with these other things. But hey, in this course, I have to be a little bit more precise about things. Okay, now, the first thing is it says it takes a list of students and returns a list of student IDs. What is missing is each student is a dictionary. Each student in the list is a dictionary with properties, and I would have to list it off: ID, name, and GPA. Okay, so there we go. All right, so I would do this, and then I would probably go a little bit further, and I would say, here's some sample data. Okay, and that's really where the things would begin. All right, so unfortunately, no, it's not just print hello. Okay, that's infs1201. All right, but here we go. This is a bunch of student data. Hopefully it fits. So there we go. Normally, I would probably format this to fit better, but hey, I'm just running a little bit short. The only thing that I really kind of dislike here is that when I put this together, apparently my finger slipped and I hit it on the caps lock, and everything got listed as uppercase GPA. All right. For dictionary property names, it's sort of okay. I'm not going to go after marks for this, but really, to be honest, I would normally do this. Okay, it isn't one of those PEP8 standard type things where I'm constantly saying, no, you can't use uppercase letters. But if you use them, it just means that you've got to remember to type them in whenever you're trying to ask for somebody's GPA. So it's easier, and that's what we always want, is things that are easy. if they're all lowercase. Okay? All right, so who should be on the honors list? Okay, well, we're talking about Faisal should be on the honors list, Nasser should be on the honors list, but it's only 2. Okay, so it's a pretty short list, but hey, we're talking about the absolute highest honors. Now, the list, we're not interested in the person's name, but we appear to be interested in the person's ID, because that's what the question says. It says return a list of IDs. Now, normally what I would do is I would have some kind of a statement down here to say, okay, here's a sample run. Okay, and I might say something like this. I may say honors, academic honors, and of course our job is to write the function, provide the students, and then what I might do is I might just print the honors, and I should see the IDs of the people with the high GPAs. Okay, and I would usually put in an expected output, and I might say like that. Okay, but of course with real data. Okay, so our job in terms of writing functions is to write the function like this. Here's the sample input that we want you to deal with. What about if somebody provides a student without a GPA? Okay, well, unless the problem says that you have these, you can assume that everything always has the same correct properties. Okay, I mean, that's dealing with errors. This is actually a very, very tricky situation. I usually don't make people do it unless I say right up front, in this particular case, you have to watch for it. So if I ever give you a question and I don't say anything about error handling, it means you don't need to worry about it. Okay. If I want you to deal with error handling, I will either say it or I will provide an example where there is an error that has to be handled a certain way. And I guess in doubt, ask whoever's invigilating, like, do we handle this or not? And if still in doubt, handle the error anyway. It's always safer to handle it than not handle it. You won't lose marks for doing something extra unless it says don't do it, usually. All right, so here we go. We need to write the function. All right, here's the way how I write functions. I think you've seen me do this a whole pile of times before. I don't just go and write the full code. I start with absolutely the absolute minimum that I can possibly get away with running the program. For example, if I try to run this program right now, does it run? Okay, and why? You have to know the answer to that, by the way. Yeah, the function is not defined. Of course it is. Okay, academic honors. Here we go, honors. All right, and what we're going to do is we're going to accept a list of students, which I will probably call student list. You might call it students. I don't really care. And what do I put in here? Well, nothing useful, but at least I print something to say, yeah, I'm here. So when I run this, I better see the word hello. And if I don't see the word hello, I'm going to have an issue. So let's go for it. Do we see the word hello? Bang, no, because I typed honors in the other way. Yeah, I did that on purpose, right? Because this happens, right? You make spelling mistakes. But imagine this now, you spent 20 minutes thinking about a problem. Okay, let's try to solve it. I'm going to write a loop. I'm going to have an if statement. I'm going to have a result set. You completely missed something really critical and simple. Just fix the simple things. All right, find out why this doesn't work. Well, hopefully it just says academic honors is not defined, and you look and you say, oh, that's because it's not spelled the same. All right, so let's see, any better? Oh, academic honors, it's more, yeah. Okay, so at this point right here, I'll tell you what most people do is they probably copy it and they paste it right here, and that way there's no guarantee that you won't have the issues. Good enough. First problem solved before we even got started. And again, remember, I've seen students get stuck because they've got indentation problems and missing quotation marks and so on, and they're just missing completely obvious things like this. Okay, so little piece at a time. All right, obviously this is no good. It just prints hello. All right, I'm going to change it. I'm going to print the student list, because if I don't see the full student list, there's no way this whole thing is going to work. And this could happen because maybe you accidentally typed it down here incorrect. Okay, and bang, of course now the whole thing doesn't work. All right, so yeah, use what we can, okay, to get us sort of started. All right, now, so my question that always I bump into whenever I'm trying to solve a problem like this is the information I'm looking for in the data that I have? Okay, so remember what we're trying to do. We're trying to find students with high GPAs. Do I have GPAs for all the students?
Yes.
Yeah. If I didn't have GPAs for the students, what this means is that I might have to calculate the GPA for the students first. Okay, and that would be a hint to say, hey, this is what we need to do. Okay, like for example, if I had the number of credits and the number of units, then you might have to do the calculation. Or maybe it's very complicated and it's a list of courses with the grades. Okay, it would be very complicated. Realistic, but complicated. Do you have the information that I need? And the answer in this case is I do. It's really hard to read in this jumbled mess, but I know that the data is there. Okay, so what we're going to do is, well, once ever I get a list of things, you know, the first things I do is I'm only interested in a few things, but hey, let's just go through everything. Okay, for X in student list, print X. You know my stance on this. I don't really like the variable called X, but it's good when you don't know what else to call it. But once you figure out what it is, change it. All right, so I'm going through and I'm printing a whole bunch of these things. What would I call each of these things that I printed? Here's one right there. Sorry, that's too much stuff. There's one of those things that I printed. What would you call that? And please don't call it data. Yes, I know it's data. It's also a dictionary. Don't call it a dictionary. What is it? What problem?
Profile.
What is this?
Profile.
A profile. Okay, I would be willing to take that. I might just call it a student because, I mean, it's a list of students, so it's a student. If you want to use a student profile, you can come up with the name. Just put it into a context of what you're trying to solve.
Yeah.
Okay, so yeah, we can call it a student. If you're really lazy, feel free to abbreviate it. Okay. Small loops like this, I don't mind single or two-letter variables. I don't like it here because that kind of obscures what I'm passing in, right? Because I'm passing in S. I don't know what S is, okay? But now I know what's being passed in. It's a list of students, okay? So you use the names to your advantage when you need them. For ST and student list, well, it's a student list, so therefore what is ST? It sounds like to me like it might be a student. And even the letter S might be all right. Now, the problem is that this is printing absolutely everything. I'm not interested in everything. I'm interested in only the people with the really high GPAs. Okay, so how do you print only some things and not others? Let's call it an if statement. Okay, so here we go. We're going to make an if statement. I don't know what we're going to do, but we're going to print ST only if the condition is true. Okay. All right, now, I've already got it printed over here. That's perfect. So what's the condition? Well, the condition is I would have to go to ST, okay, but you can't say is ST bigger than or equal to 3.5 because that's, of course, a full student. And sometimes I get students trying to do this. And what it's going to do is going to say, well, I can't compare a dictionary to a float. Yeah. Okay, now, wait a minute. Dictionary, float? Yeah. We'll do a print to find out what it is. Oh, yeah, it's a dictionary. I can't compare a whole dictionary to a float. I can compare one part of a dictionary. Well, remember, ST has a whole bunch of properties. One of the properties that it has an ID. Oh, but that's not what I'm looking for. I don't want to know if the ID is bigger than this. I don't want to know if the name is bigger than this. I want to know if the GPA is bigger than this. Okay, let's get rid of this one. Otherwise, it'll be too many prints. And if we go off and run it, again, previously, I saw everything, okay? So the information I was looking for was there, but I had extra stuff. So the next thing I did was I get rid of the things that I'm not interested in. So the only thing left is, this is exactly the information I'm looking for. I know that 60301234 should be on the list, and 60307890 should be on the list. Well, let's filter this a little bit more because I don't want to see all of these. I'm just really interested in, say, the ID. Okay, we're getting a little bit closer. It still doesn't solve my problem, but we're actually really, really close. Okay? The problem right now is that my function prints the data. But you know what? Having the function print the data that I'm looking for is better than having the function, like, do a bunch of weird stuff that I'm not even asking for. I mean, at least it's a little bit closer. But the thing is I don't want to print it. I want to send this back. All right, so here we go. First thing I'm going to do is, maybe not correct, but I'm going to do it anyway. All right, I want to return the ID. Well, there you go, just return it. Okay, here's the issue with this. When you run this, you only see one thing. Okay, now the reason why you see only one thing. All right, so first of all, I mean, that's good. We only see the ID. That's actually positive. But the thing is, I'm supposed to see two IDs. The reason why we only see one is because of this line right here, which is a return. Return does two things. The first thing it does is it immediately stops the current program, the current function, and it does not continue no matter what you're doing. It doesn't matter if you're in the middle of an infinite loop, a return stops the function, okay? And it doesn't go any further. That's why I only see one. As soon as I found one, I am finished. The second thing that a return does, the return says, we'll take what I just found and send it back to the person who called it. And that's why when we printed it, it kind of worked, okay? Because the function found one student and it returned it. But the issue is, I don't want to get just the first student. The function isn't tell me one academic honors student. That would solve it. What I'm looking for is I'm looking for a list of academic honor students because, well, we assume that there's more than one. If the function was give me the ID of the person with the highest GPA, okay, that can return one thing, but this is return multiple things. All right, always, 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 this is how I deal with returning multiple things from a list. I have an accumulator. Okay, we've had accumulators before. They were called total back in 1101 at the beginning of the semester. You have total is equal to 0, and every time that you find something, you add something to it. And it keeps getting bigger and bigger and bigger, and eventually you return total. So this will not run, by the way, but it would look something like this. You would say, don't worry about it, okay, you'd say total is equal to total plus some value, and at the very end, you'd return total. Okay, remember that? Obviously, this doesn't work because we're not trying to solve this problem, but what I'm trying to do is actually exactly the same programming pattern. We're going to start with an accumulator that starts with nothing. Now, remember, what I'm trying to deal with is I'm trying to deal with a list of students who are on the honors list. So what I'm going to call it is maybe the honors list, and I'm going to start with absolutely nothing. That's the accumulator basically being initialized to 0. Instead of returning something, what I'm going to do is I'm going to go to the honor list. And how do you add something to an honors list? Yeah, dot append. Dot add is for sets. Okay, it didn't ask for a set. It could have, and then we'd have you dot add. We'll change that in a minute. Okay, here we go. Append. And what do I want to append? Well, I just want to append the ID, which we printed a few seconds ago, but obviously I don't want to return. Okay, so that goes. And fix my syntax error. All right, and of course at the end, what am I going to send back? The honor list. There you go, there's the two students. Okay. We can check it by giving somebody else a slightly higher grade, so there you go. Okay, that's pretty reasonable. And what do we do if we take this person, make it a 1, make it a 1? What do I get back? Yeah, I get back an empty list, and that's consistent because those are the students who are honor students. Okay. Yeah, there's nothing. Okay, an empty list is a perfectly valid thing to return back. Okay, let's go back to our original number. Here we go. All right, perfect. We're finished, almost. There's really kind of one thing left, and that is, yeah, write up a doc string, and you can describe now what it's doing, what it is, except basically, okay, well, okay, as silly as it is, there you go, we'll copy and paste it. All right, now, for the questions that we asked on the midterm and the lab exam and all of the other things, yeah, you can probably get away with mostly copying and pasting because you're not the one designing the function. So, and chances are somebody has given you enough details, because if we don't give you the details, you're going to come up with something completely strange. If you continue on in programming, however, it would be up to you to come up with the description that goes in here. Okay? All right, but I will leave these out just because it makes it just a touch easier. But over here in the slides, we've got it. All right, because I just said this, or somebody suggested about the dot add, and I said, no, that's a set. Okay, let's change it to a set. Let's suppose somebody said, hey, I want to turn this into a set. Okay, what's the difference between a list and a set? So lists are ordered, sets are not.
Yeah.
Okay.
I can't change the set.
You certainly can. You can change the set. Yeah, you can change the set. All right, so you can do that. But the other thing about sets is you won't have duplicates. Okay, is that going to be a problem with academic honors students?
No.
No, because somebody should only appear once. Okay, so it's okay. It could be a set. Let's change the problem into a set in two different ways. Okay, so instead of having an honors list, oh, do you know what? I'll be quite honest what I call this all the time. Just a variable name. I call it result because this is the thing I'm going to return at the end. All right, let's turn it into a set. Okay, do I start with an empty list? No, of course not. What do I start with? An empty set. How do you spell an empty set? Empty set. Oh. No.
No, it's
Yeah, unfortunately, the curly brackets like this is a dictionary. Yeah, okay. To create an empty set, it looks like this. Okay, it's the word set with a set of parentheses. And obviously, if I try to do this, it'll blow up because, well, set has nothing called append. It has. There you go. All right, wasn't difficult, was it?
No.
Okay, let's do it a different way. Okay, there we go. That's the list. Okay, ready for this one? All right. Just turn it into a set at the very end. Yeah, you can convert between sets and lists without a problem. What if I want a tuple? Oh, okay, so I would start with, oh, no, you can't do that. You start with tuple. Okay, and what's the function to add something to a tuple?
Nothing.
Okay, good answer. Yeah, it doesn't exist. Oh, so therefore I can't do it. No, you can do something like this. You can say that this is equal to this plus something like this, and then you could return the result at the end. Sorry, I forgot to undo that one. All right, so you could do that. Okay, but to be honest, I wouldn't do it. What I would do instead is, since we already have this thing working for lists,
Just change it to a tuple.
yeah, just change it to a tuple and it's done. There you go. So now you return a tuple. Pretty easy, right? Conversion, yeah, just typecast. That's it. It knows how to deal with it automatically. Okay, next one up. Okay, another function. Come on, where did my text editor go? Okay, Omega, good, okay. Write a function called find student GPA that takes a list of student dictionaries, and I would have to say the dictionaries contain the following items, it's the same ones, and returns the GPA of that student if found, but unfortunately we might get to a situation where the student isn't found. If the student is not found, then return none. Okay? All right, so this is often how these things look. And of course, I would provide an example. Okay, so for example, okay, I'll remove this, but I'm going to leave the academic honors. No, we'll get rid of the academic honors. No reason for this. Okay, so here we go. So we're talking about this. We're talking about having like a GPA. We're talking about saying find student GPA. We're going to pass in the full list of students, and I'm going to give an ID number of 60302345. Okay, and I'm going to print the GPA, probably with a statement. All right, when I run this program, obviously if I run it right now, it doesn't do anything because I haven't written the function yet. We'll write the function in a second. What do we expect to see as the output? Okay, yeah, good answer, none. Oh, why? Because, okay, small technicality. This is a string. This is an integer, and you'll never be able to find it this way. All right. Now what am I expecting? No, I found, but I'm printing the GPA.
Yeah.
So what do I expect the value GPA to contain? I think 3.2. Okay, because that is the person's GPA, right? 6030235.
Yeah.
Yeah, I'm expecting a 3.2. Okay, 3.2 for this one. If I ask for something that doesn't exist, I should say none, or should see none, not say none. All right, so off we go again. Same idea. Process, okay? Find student GPA. It takes a student list as a parameter, and it takes the ID of a... I'm not supposed to use the letters ID because that's used for something else. So whatever you want to call it, maybe student underscore ID. If you want to use SID, it's completely fine by me. All right, just a simple message. Okay, I'll be honest, what I use is blah. Okay, if I run it, I see the word blah.
Yeah.
I also see the word none because what did the function return? Nothing, so therefore it defaults as none. Sometimes what I will do is I'll return the message like not yet. Okay. Okay, at least I can let the rest of the program work. All right, so I don't have any answer for you yet, but eventually I'll get there. All right, what do we do? Well, are we interested in all of the students? No, we're interested in just one of the students, but same deal as what I did last time. I'm interested, I just want to see, do I have what I'm looking for, okay? And to know whether or not I've got something I'm looking for, I could obviously do a print of a student list. Sometimes I will do this, and sometimes I'll print the student ID just to make sure I've got all of the data. But just like what I did last time is whenever you're dealing with lists, a lot of, especially lists of dictionaries, a lot of the time it is going to be iteration. I mean, it happens so often. You saw the bullet point was duplicated. So guess what? For ST in student list, print ST. All right, do we see the information that I'm looking for, which is the GPA of 3.2 for 6030235?
Yes.
And the answer is yes, I do see it. It happens to be this record right here, okay? But it is a list, and the only thing I can do is to iterate through. Now, sometimes what students will pop into is they may say, could I do something like this? Could I say, just print, whoa, here we go, print ST at like GPA, student ID? And the answer is no, sorry, you can't do that because indexes are small numbers like 0, 1, 2, 3, and so on. I can do this, but the problem is I don't know what's actually going to be in this location, okay? All right, so here we go. Back to here, I can definitely see this. I'm interested in just one of them. I'm not interested in all of them. So just like I did last time, if, okay, ST, which is an individual student, well, I'm searching now on the ID. If that's equal to the student ID, well, then let's print the student. Okay, let's try this one. All right, is this the information I'm looking for? And the answer is yes. I mean, it contains extra things. Okay, but this is the information that I'm looking for, so I've been able to filter it down. I'm not actually solving the problem yet, but I'm getting really, really close. I'm not interested in the person's name, not interested in the ID. The only thing I'm interested in is their GPA. There we go. So there's the thing that we're looking for. Now, the thing is I need to send this back to the person who called. Oh, and how many students will possibly match? There are two answers to this. How many students will have the ID, will have this student ID right here? Okay, either none because we didn't find it, or one. Will we ever have two students with the same ID? No. So therefore, you never return it as a list. It would be a single value. So if you were to design the function, which luckily you don't have to in the tests that I do here, but if you were to design that function, you wouldn't return a list of student IDs, you'd return, or sorry, a list of GPAs, you would return the GPA. Same thing, you wouldn't send it back as a tuple because you're only asking for one thing. You wouldn't send it back as a set. You wouldn't send it back as a dictionary. That doesn't make any sense. It's one value only. The good news, as I said, in the course or in the tests, I don't give you this option. I simply say, this is what you're going to return. All right, well, how do you return something? Pretty simple. Instead of printing it, you return it. Oh, but that's only going to find one. Well, that's fine because that's how many there are.
Yeah.
Okay, now what happens if I ask for, say, this one right here?
Edit.
okay, so we decided in the description it should return
Okay.
none. Okay, that's what I decided. It was going to return none if we don't find something.
Yeah.
And right now it returns not yet because it made it to the end of the loop, it never found it, and what I'm talking about is returning none. Okay, done. Sometimes I will see students do this, so I will warn you about that, and you'll say, yeah, it works perfectly fine. No, whenever you see an instruction to say, please return none, it's talking about the value none, not the string called none.
Yeah.
And the reason for this is because people are going to write things like this. They're going to say, if not GPA, print didn't find the student. Okay, otherwise we're going to print the GPA, and this will end up possibly causing you some types of trouble. Like, for example, right now it prints the word none, but it didn't find the student, and that's because
It's still that.
it was a string rather than the actual type. Okay, so that it really is kind of important to either put them in if you want the string none, which we never do, or leave them out because that's what our testing code goes. I have to warn you about this on the tests. Okay, the way how the instructors grade the tests, they will take your function and only your function, and they will drop it into another program called a testing harness. And what it does is it tries a whole bunch of different things with your function. Okay, this is the way how they're taught to grade, because otherwise, for an instructor to look at it, there's going to be cases where they're going to miss things. Okay, so this way we can try exercising a whole bunch of code. We've got rules. What happens, do you think, if you misname the function?
If you misname the function.
Yeah, it doesn't work. Okay, so now, one approach is the instructor to just say, yeah, it's 0, doesn't work.
Yeah.
Okay, we're not quite this harsh. If you find that something is misnamed, they will fix it. Okay, it'll cost you some marks, but they will fix it, and they will try it again. But what if your function didn't take a second parameter? Well, they're not going to fix that.
Yeah.
Okay, so there's limits about what they can fix. Simple spelling mistakes, they will make some adjustments. But you see, if you're returning the wrong type, almost all the tests, or a bunch of the test cases, are going to fail, and nobody's going to say, oh, well, they just put this. Yeah, you're going to lose some marks for it. So you have to follow the instructions very, very precisely. And this is actually true in industry. This is the way how things work. If the senior developer says to a junior developer, please go off and write me the following functions, and this is what they take as parameters, what they return, that is what the senior developer is expecting.
Yeah.
Okay, and you can't go back and say, well, I thought it would be easier to do this. The senior developer could care less what you think is easier.
Yeah.
Okay, you have to follow instructions very, very carefully. Okay, so that's the one quite often people end up messing up on, is none versus none. All right, next one up. Okay, this is a slide. I can cover this one. All right, so a dictionary has the advantage that it can quickly find something given its key. Remember, we did this last class where we had all of the course codes as the keys and then the names of the courses as a value. And it was really cool because we could very quickly go and find some information. Okay, we didn't have to loop through. And yeah, putting things inside dictionaries, sometimes we do this if you want to be able to find things quickly, because we can avoid the loops. Okay, it's faster for everybody. It's faster for you. It's faster for the computer. Everybody wins. Okay, so now, what is it that we're talking about? I am going to go back and I'm going to redo some work once again. Ooh, we'll start from nothing. Okay, and we'll pull over one piece of information at a time once I can get a hold of it. Okay, here we go. There's some data. I'm going to not indent it. It's driving me crazy, but I'm not going to indent it just so that we can see everything without having to slide back and forth. Okay, so here we go. It runs, it just really should be indented. All right, is this the same information that I had a minute ago? And the answer is yes, it's all the same information. However, it's a different data structure. You see, previously, I had a list of students. Now I have a dictionary of students. Okay, what's the difference? Well, instead of square brackets, it's now curly brackets. Okay, remember, dictionaries have keys and values. The keys are the ID numbers. Now remember something important about keys in dictionaries: you're not allowed to have duplicates. Oh, but in a university, can you have two students with the same ID? No. So it kind of works really well for this because it's a very, very natural fit for it. Okay, so here you go. Here's a dictionary full of students, got all the same information. It just happens to be a dictionary rather than a list. Okay, here we go. Let's write the same function. GPA, find student, GPA, pass in the students, and we're going to look for 60302345. We already know the number.
Yeah.
We know that this is supposed to print. Okay, here we are. GPA. This should be printing 3.2. Right? I think yeah, 3.2. All right, so how do we deal with a dictionary and how do we find something, or how do we deal with this when we go through and deal with find students, GPA? All right, well, it turns out this is actually really simple. Okay, here we go. Find student GPA, student, what do you think? Student list? You know, I don't really like it because, is it a list? No, it's not a list. And if you call it a list, you're going to be confused and eventually you're going to do a dot append. You're going to iterate through things. Probably not something that you want. Okay, so here we go. Anyway, let's not call this, so unfortunately, it's not a student list. I don't know if I really want to call it a student dictionary, but you can. Okay, that's fine. To be honest, probably what I'd call it is just students. Okay, pretty generic. But if you want to use the word student dictionary so it's very clear in your mind what it is, that's not a bad approach. Okay? All right, so good. Good so far. At least my function is working. All right, so what do we do? Well, first thing, print students. Do we see all this? Do we see the information I'm looking for? Yeah, I see the information. Okay, good. Same approach as before, right? You set up and you say for X in students, print X, and we see what comes out. No, that's not what I want. That's just the IDs. Because remember, when you set up a loop, when you set up a for loop on a dictionary, you get back the keys of the dictionary. Okay, we get the keys of the dictionary. All right, so now you start to think, you say, okay, you know what? I've got a whole bunch of other things in here. Okay, so in other words, this is really the student ID. I'm going to call it STID. And by the way, this is not a very good approach that I'm doing. Okay, but it would solve the problem. All right, the issue with this is I'm only seeing the student IDs. Where's the rest of the information? Well, the rest of the information is in the student's dictionary at position STID. Oh, but I have to use the correct bracket. Okay, do we see the information I'm looking for? It's there.
Yeah.
Okay, but of course I'm seeing too many. Well, we know how to deal with the too many things, right? How do you deal with too many things? We just did it. Yeah, if statement. Okay, so you can start asking questions like, well, what if students if STID is exactly equal to student ID, and by the way, what I'm doing here is absolutely pathetic, so don't look and say, hey, this is easy, and we'll be all finished. There you go. I'm down to the single student. Okay, good. But I'm seeing too many things. I only want to see the GPA. Oh, sorry, it's capital GPA this time. Okay, we'll just leave it. All right, I'm seeing too many things. I don't want to see the student ID. Okay, I don't want to see all this. I just want to see the GPA. All right, so instead of printing it, what do you think I should do with it? Well, return it, right? And at the very end, the same as last time, return none. Okay, there you go. This is an absolutely terrible implementation. It works, but it's a terrible implementation. All right, so if I asked you to do this on a test and you gave it to me, I would probably go, oh, and I would give you the marks anyway. Okay? Because you spent a whole lot of time doing a lot of stuff you didn't need to do. So I might feel sorry for you and say, okay, well, at least I got it to work. Okay, here's the problem is, or sorry, not the problem, but the thing about a dictionary is if you're looking for something given the key, which we are given the key, it's actually really, really simple. You see, if I were to simply print students at student ID, That's exactly the data that I'm looking for. Oh, and of course, I'm not looking for everything. I'm just looking for the GPA. There you go. There's just the GPA. Instead of printing it, all that I need to do is to return it. There you go. Hey, that was pretty easy. Yeah, you don't need a loop for this because you know the key. If you know the key, you can go directly to the item. So all that I've done is I've taken this one. Now, the question becomes is what happens if I ask for something that's not there? You get a key error. Now, if the function says I have to check and return none, I'm not allowed to do this. I know the program crashes, but that's not what I want. I want the program to return none. What I would have to do is I have to use an if statement, and you'd have to check, is the student ID in students? If it is, then I'm going to return that. Otherwise, I'll return none. Okay. Now, that is considerably quicker and easier for you compared to doing a loop. It's also a whole lot easier for the computer. Okay. Now, that is a better way. This works only because I was given the key. If I'm not given the key, it doesn't work this way. All right, to save myself a little bit of time, let's go over to the slides for a second because I think the next example is very similar. All right, so there we go. Find the student, find the student's GPA given the student ID. If I changed the problem and I said find the student given a name, this is a considerably different problem. So here we go. This is what this ends up looking like. So take a look. What I've done here is I have gone through. Here we go. Oh, in fact, you know what? I might as well just copy this over. Okay, I won't write it, but I'll copy it over. Okay, and then this way we can at least try a couple of things. Okay, so this one right here, given its name, so we're talking about finding somebody like Amina Al-Obaidli. Okay, there you go. And for some reason, this is returning like a bunch of things. So I guess the problem is a little bit different. All right, this was returning the ID and the person's GPA. Could have been just a GPA, but in cases, find students, find other information about the student. Okay, just different problem, that's all. Okay, so remember what student list.items is. Okay, first of all, let's undo this. And I'll just print, oh, sorry, 4x, x. Okay, so to remind what the student list.items is, the .items operation from a dictionary returns a bunch of tuples. Okay, it returns a whole bunch of tuples that you can iterate through. So every time you're through, you get exactly one tuple. The first entry in the tuple is the key. The second entry is the value. So this is all of the information. So what I'm going to do is instead of calling it X, what these are, this is, well, a student record. But more precisely, this is a student ID, so I'll call it stu ID this time, and maybe student details. Stu details. Stu ID and stu details. Okay, here we go. So there's still the same information. Okay, and yes, we are iterating through. So at this point here, what we can do is we can start to ask some questions. Okay, I've got one of these out of whack type things. Okay, I think everything is okay at the moment. Here we go. All right, so what I'm going to do is I'm going to start asking a question. If the stu details name happens to match the student name that I'm searching for, well, then what I'm going to do is I'm just going to print some stars just for right now. Okay, so there you go. So it did find it. Okay, I'm not interested in printing it here, but I'd probably be interested in printing it down here. So here we go. Student details. Oh, sorry, stu details. That's what I get for trying to shorten it. There you go. That contains the information I'm looking for. And if we're interested in just dealing with the GPA, which is kind of a match for what we were doing before, we know it's the property GPA. And of course, instead of printing everything, we're probably going to end up returning it. All right, there we go. So there's the solution for this one. That is finding a student GPA based on a name. Very, very different than finding based on the ID. The ID is a key. All you do is use square brackets, you go directly to the item. If you're looking for anything based on a value, you have no choice but to iterate through everything. The dot items is usually how I'd end up doing it, okay? If you have the ability to use the key, you want to use it. Okay? And obviously you can see it's much faster because you don't have to write the loop. Less loops you write, the less likely you'll end up with some problems. Okay? And that's true of everybody. I try to avoid them, not because I'll have problems, but because I know it's going to be faster for the computer to go directly to a location. All right, next slide, and then we're finished. Okay, and then we'll just have a quick little chat about what's going to happen over the next couple of weeks. All right, and safe access. So remember to make sure that the key always exists before accessing the inner data. There's the problem. If you just go directly, okay, and I showed this, if you just go directly to a student ID and try to pull out the GPA, it will blow up. You really need to find out whether or not the student is there first by using an if statement and say if the student ID is in the student list, which it isn't a list, it's called a dictionary, so I'll fix that one. Or you can always use the .get, which will avoid the crash. But to be honest, I prefer the approach with checking to see if something is there, but again, on a test, I would accept either of those. Oh, excellent, so that one is done quick. All right, I know tradition, I would usually pull out a Kahoot and make everybody bored again, but let's not do that today. Okay, let's pop over to here. So just one quick little thing just to remind you what's happening over the next couple of weeks. Oh, yes.
So which lecture we have to study for the exam?
Yeah, okay, so that's a reasonable thing. Okay, I will answer that. Okay, not quite now, but almost. All right, so here we go. We're down to dictionaries and nested structures. We just did that. We've done the quiz this week along with exercise 6. Very important. Do not forget to stay home next week. Okay, usually people remember that one. All right, so yes, it is going to be a break. Please don't forget about this course. So don't use it as a complete break and empty everything from your mind. Please use it as a time where you're not overwhelmed with a whole lot of other things and continue to practice on all of your courses, in particular this one, okay, because of course we've got a midterm coming after. All right, during the lectures, right after the break, yes, I will not cover anything new. I'm sorry I had to cover new things this week because I had no choice, otherwise we're going to run out of time. But what I will do for the full week beforehand is we'll do a small review. What I will do is I will pull out a copy of the midterm from winter and we'll solve it. One day we'll go through the tracing questions very carefully. The second day we'll go through the programming questions that I included. Okay, so we'll do that. I'll also make a copy available for you, and you will drop it out. And you can take as many times as you want if you want to do some practice with it. Okay, during the labs this week. Sometimes what I do is I will give you more review during the labs, but because of scheduling, I just couldn't this time. So sorry, it is an exercise set, and usually I don't include like an evaluated lab, but again, just because of scheduling, because we missed this week, I had no choice, okay? And of course, the midterm will be on October 25th, which is really unfortunate. I've said before, I apologize for dragging people in on a Saturday. I have to come in as well. In fact, I have to come in for a whole bunch of midterms for other courses. Sorry, it's the only way I can keep it fair, okay? Sometime during this week, I hope sometime during this week you might see the assignment may appear or it might not. Depends if I can get it distributed to people or not, which will just give you a little extra time to work on things. The exercises I've got are really cool. They're a bunch of nested structures. You don't need it for the midterm, but it's going to be really, really good work for the lab exam, which shows up like a month later. Okay, so if I don't get to it during the break, I'm almost done, but you might not see it. Don't worry, you're not going to be far behind. All right, so next one up, somebody's asked about to which things are included. Okay, that's completely fine. This is why I do include the. I always include details about what's going on so you know exactly what's happening. Okay, so there is a news posting item. You can take a look at that. In midterm, it's 20% of your final grade. Okay, it'll be an 8 a.m. thing because the later in the day slots were all taken. I will send you the room locations just a couple of days before, because sometimes we have to change things. All right, here we go. The format, there will be 12 MCQs. Those are basically the tracing questions. They will be worth 25 points. Some questions may be worth 1, some questions may be worth 3. That's why the odd numbers are here. Usually what I do is like the really trivial things, I might just leave with 1 point. The more challenging things, I might make 3 points. Just to warn you, this could happen. There will be 2 programming questions. One, what I call a standard question, worth 20 marks. So that is like almost 50%. And the idea behind this one is this one should be fairly straightforward. It shouldn't be anything completely off the wall. It should be somewhat straightforward. It won't be trivial. Guarantee it will never be trivial. Like it won't be like calculate the average of this, because that's way too simple, but maybe you have to calculate averages of like certain things, these types of issues. If you don't get that program to work, the good news is that the instructors will be somewhat lenient on the grading, and you may get some marks for the correct algorithm. Although generally when I find it doesn't work, the algorithms are really, really bad. All right, but there will be some partial marks for some things. And there will also be one challenging question. It's only worth 5, so that's like 10%. It's a little bit more challenging. You'll see the examples just be in the review. And basically, it's all or nothing on those, or most or nothing. So in other words, if you don't get it really exact, then the instructor should actually give you nothing. That's generally how this ends up working. Okay, in every question, you will be asked to write a function. Okay, might take a parameter, maybe multiple parameters, maybe you have to return a result. In terms of topics, slides 1 through 10. Okay, so for this, we need to have a list of the content so we know exactly what it is that we're looking at. Okay, here we go. Lecture section content. Lecture section content. So we are talking Python basics review, primitive types and expressions, looping. These are things you've seen before, so don't expect a lot from them. Those might be like the 1-pointers. Okay, for loops are new, so that's reasonable. Writing functions, I mean, you've seen before, but some variable scopes and so on. List basics, list operations and mutability, and nested list, but not tuples and sets. Okay, so right up until tuples and sets, but those are not included. So dictionaries, not included. Tuples and sets, not included. Don't worry, we'll get to see them in the lab exam. Okay, but just in case you're wondering what's happened to them because you found them fun. All right, exercise sets 1 through 6, that just matches up to exactly the same thing. The evaluated labs 1 through 4, basic programming, lists and functions and so on. And quiz 1 and 2. Quiz number 3 is also fair game, but we don't do it till after the midterm, so I guess that's out. And I think the programming exercise was more important. All right, so during the test, just to remind you, and you'll see this, I'll show you the example. Basically, we take the test and we split it into 2 pages. The first page is a big long pile of MCQ questions on 1 page. This way you can answer whatever questions in whichever order you want. And of course, well, you know that there's a button called Next, and once you click on the next button, you can't go back to the MCQs. Okay, that's it. At that point, you now are in programming mode. You'll have access to the interpreter. Sometimes I get students that come in, the first thing they do is they click Next. Yeah, that's probably not a good idea unless you just want to give up like the first 50 points. Okay, so don't do that. If I see it happen right away, I might be able to reset it, but just don't do it. Just don't click Next until you're ready. All right, in terms of what can you bring, we'll bring in the pencils as usual, paper, but there's nothing you're bringing in. Okay, we don't need a calculator. One will be provided in D2L. No, there's no notes that you're allowed to bring in. There's no cheat sheets, none of this stuff. These are things that I expect that you'll be able to deal with on your own without having to look at examples and so on. Okay, all right. So there you go. That's what's involved with the midterm. So basically, up until sets and tuples and dictionary. So none of those. Lab exam, we'll see. Okay. All right. All good? Okay.